Welcome back to our channel 18 Slices of Me. Today, we are diving into a fascinating topic, classical versus quantum computing. What are the key differences, and what advantages does quantum computing bring to the table? Let's find out. 1. What is classical computing? First, let's talk about classical computing. Classical computers, like the one you are using right now, process information using bits. Each bit is a binary unit, either a 0 or a 1. These computers perform calculations sequentially, which means they handle one task at a time. Classical computing is powerful for many applications, from word processing to complex simulations. However, it has limitations when it comes to processing vast amounts of data or solving certain complex problems quickly. 2. What is quantum computing? Now, let's shift gears to quantum computing. Quantum computers use quantum bits, or qubits. Unlike classical bits, qubits can exist in multiple states at once, thanks to a property called superposition. This allows quantum computers to process a massive amount of possibilities simultaneously. Additionally, qubits can be entangled, meaning the state of one qubit can depend on another, no matter the distance between them. This leads to unprecedented computational power. 3. Key differences. So, what are the key differences between classical and quantum computing? Data representation, classical, bits, zeros and ones, quantum, qubits, superposition and entanglement. 2. Processing power, classical, sequential processing, quantum, parallel processing. 3. Problem solving, classical, best for routine tasks. 4. Advantages of quantum computing. Now, let's discuss the advantages of quantum computing. Quantum computers can solve certain problems exponentially faster than classical computers. For example, they can factor large numbers, which is crucial for cryptography. 2. Complex problem solving. They excel in optimization problems, making them valuable in logistics, finance, and drug discovery. 3. Simulating quantum systems. Quantum computers can simulate molecular and atomic interactions, paving the way for breakthroughs in materials science and chemistry. In conclusion, while classical computing has served us well, quantum computing holds the promise of revolutionizing technology and solving problems we once thought were insurmountable. As we continue to explore this exciting frontier, the future looks bright. Thanks for watching. If you found this video informative, don't forget to like, subscribe, and hit the notification bell for more tech insights.